Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video, we're going to take a look at Plotly, which is a framework for data visualization and graphing. We're going to use it in Python, but as far as I know, it's language independent, so it's also available for JavaScript and maybe also for some other languages, but I haven't looked that up, to be honest. We're going to use it in Python, and we're going to compare it a little bit to Matplotlib, because I have used Matplotlib in countless tutorials on this channel, and we have never used Plotly, so we're going to compare them a little bit. We're not going to use Matplotlib in today's video at all. We're just going to talk about the differences. We're going to focus on Plotly, so we're going to cover the basics here. But in the end, I'm going to give you a conclusion for when to use what the pros and cons are of the different modules. And yeah, we're going to talk about this today. But before we do all that, we're going to talk a little bit about the development environment, because today we're going to do something new. We're not going to use PyCharm or a simple editor. We're going to use a Jupyter notebook. Now, for those of you who don't know what a Jupyter notebook is, it's basically an application that is running in the browser, and you can edit individual cells. You can code in individual cells. You can run individual cells. And it's, you could say, optimized or very good for data science and machine learning coding, because then you can just, execute a cell where the model is trained, and then you can use the trained model without having to run the whole script all over again. So you split the code up into cells, you can run them. You're going to see what I'm talking about in a second. What we're going to talk about now is how to get the Jupyter notebook. And as far as I know, it's installed by default, but if you want to run it by default, you need to say python-m notebook. Now, I'm not sure if that works if you haven't installed Jupyter yet. If you haven't installed it, just say pip install Jupyter, or was it Jupyter notebook, one of the two. Just play around with that. But what I would recommend you do is you set up an Anaconda environment. Now, if you want to have a tutorial on how to set up Anaconda, let me know in the comment section down below. I'm not going to do it now because today's video is focusing on Plotly, not on installing an Anaconda environment. But if you have Anaconda installed, you also have a Jupyter notebook by default. You can just activate an environment that you have created. Data science is what I called mine. And in here, you can just say Jupyter notebook like that. And then it's going to open up your web browser, and it's going to open up Jupyter Notebook, and then you can just navigate to the desktop, for example, or to your working environment, and then you can create a notebook there. So as you can see, it's running on localhost. It's a web app that is hosted, and now I can go to the desktop and I can say new Python 3, and in the notebook I can start coding once it's loaded. Now, besides that, we're also going to install some libraries. So as you can see, this is a Jupyter notebook. What I can do here is I can say print hello world, for example, and I can run this, and you can see hello world. Then I can have a separate cell here, or let's define a variable up here. Let's say a equals 10, and down here I say print a, like that. First, I run this cell, then A exists also in this cell, but I can run this independently. So I don't have to always run the whole code all over again. And this is what we're going to work with Plotly in. I also, as you can see, have installed Vim bindings. You don't need to do that. It's quite messy and quite complicated if you do it for the first time. But the libraries that we're going to need today are Plotly, obviously. We're going to also need, so let me write that down, Plotly. We're going to need pandas. We're going to need NumPy. And optionally, if you want to work with financial data, I don't think that we're going to do it. At least I haven't prepared any financial data applications or examples here, but you can install YFinance to get some different data. You can install Yahoo-Fin. You can install Pandas Data Reader to get some financial data. We're going to just use a data set of Plotly, but again, if you have some basic experience with Pandas, you can just swap the data sets out and use something from those finance modules here if you want to. So one thing that I would recommend you is that when you install something in Anaconda, use the conda install command if possible. This is because the pip by default that you use in the Anaconda environment is going to be the global pip. Now, if you don't use Anaconda, if you don't want to spend any time on this installation process here, and you already have set it up, and you also, or you only want to learn about Plotly, then just skip that part. But if you're using conda, this might be important. So whenever you install NumPy, Pandas, Plotly, whatever, use conda install, or at least say conda install pip and then use pip, because otherwise you're not going to use the actual pip. maybe I can show you that real quick. Let's open up a second CMD. And when we create a new Conda environment, so Conda create name, and we're going to call this test_env, for example. And now I say, once it's done, come on, yes, then activate test_env. You're going to see that when I say where pip, it's going to say that this is the local pip. It's not the Anaconda pip. Whereas if I deactivate this now and I activate data science, which is the one that I have already set up, and now I say where pip, you can see that this is actually the Anaconda data science pip. So it's a different pip. So if you want to use pip for the installation, make sure you have pip installed by saying conda install pip. And besides that, also install conda install numpy, pandas, and plotly. This is what you're going to need for today's video. All right, so let's get right into it. We're going to start by importing a couple of things. First of all, we're going to import pandas, and we're going to import, actually pandas SPD. We're going to import numpy snp, and we're also going to import plotly.express spx. Oh, I used the vim binding there. So let's delete that, and let's delete that and say px. There you go. So let's run this cell, and now once everything is imported, once you see the number here, we can start with the coding. Let's do something very, very basic to see how Plotly basically works. We're going to say xdata equals mp random.random50, and we're going to say y data is the same, and now we want to visualize that using Plotly. What we're going to do is we're going to say the figure is going to be px dot, let's do a basic scatter plot for that data, scatter, and we're going to say x equals x data and y equals y data, and then fig.show. This is how you do a basic scatter plot in Plotly. If I run this now, you're going to see in a second that this is a plot. And one thing that you can notice right away is that the plot looks kind of good already without us having to do a lot of or any configuration at all. I can just zoom into a certain part here. I can auto scale again. I can do all sorts of things, and it's very easy to configure a very basic plot that looks kind of good already without having to specify too many things in advance, which is not the case for Matplotlib, but we're going to talk about that in the end. Anyway, so let's go to the next example. Let's load some data from a data set about Europe. We have some data about the European continent. So we're going to say Europe data 2007. So we're going to get some data for the year 2007. We're going to say that this is px.data.gapminder. And here we're going to query. The year is going to be 2007. Now this year is not Plotly content here. This is just loading a data set, so you can choose whatever data set you want. We're going to get continent equals Europe. Now I think we need to put that in quotes here. And we have an error. What is the problem? Oh, of course, we need to use double equal signs because that's a query. There you go. So once we have that, we can print the data set as well by just saying print Europe data 2007. And you can see that we have the country names, we have the continent, we have the year, in this case, obviously only 2007. And we have the values life expectancy, population, GDP per capita, and then some other information that's not really important for us at the moment. And with that data, we're just going to play around a little bit and we're going to visualize some things. Let's start, first of all, with some basic data inside of a scatter plot, but we're not going to just have some basic data points. We're going to include some information in the size and in the color of the individual bubbles, you could say, as well. So what we're going to do is we're going to say figure is again px.scatter. And we're going to say the x-axis is going to be the life expectancy, or first of all, we need to pass the data set, Europe data 2007. The x data is going to be the life expectancy. Then the y data is going to be the GDP per capita. And then we can define the size of the individual bubble to be derived from one of these values. So we can say, okay, the size of the bubble, it makes sense if it's the population. So the bubble is going to be bigger if the country has more citizens. And then we're going to also say the color. This is going to be a little bit redundant, but we don't have much more information to work with here in this case. We're going to say the color of the individual bubble is going to be the life expectancy as well. Now, of course, if we have a fourth column here with some data, this is not really data. If we have an actual column here with, I don't know, degree of happiness or something, we could use that. In this case, we use the X value and the color. For the X value and for the color, we use the same column. So what we do now is we say figure.show. And when we run this here, you can see that this is already a very good looking plot. We have the individual bubbles. You can see that here we also have the color scale. So this means a lower life expectancy. This is a higher life expectancy. And you can see that this bubble here is quite big because we have a large population. Now, one thing that we might want to do is also the country name when we hover. So we can say hover underscore name is going to be the country so that we know what country we're talking about. Now, if I hover, we can see this is Turkey. We can see this is Poland. This is Germany. This is the United Kingdom. And somewhere below here, we have Belgium as well and Finland. We can see that Norway has a very high GDP per capita. And the country with the highest life expectancy is Iceland, as it seems. Yeah, Iceland and Switzerland. You can see the colors as well. And you can see the size, as I said, is the population. So you can see that just by specifying 3 parameters, we have a very professionally looking plot. We can also zoom in. We can see, okay, what are the details here? What do we have here? Okay, we have Belgium, we have Finland, we have United Kingdom. Then I can auto scale again. And this works with 1 line of code. In Matplotlib, this would be way more difficult. Now let's look at other types of plots as well. We're going to start a new cell. And in here, we're going to load not the Europe data 2007, but the whole Europe data. So we're going to say Europe data equals px data gapminder, and then just dot query continent. Actually, we need to pass a string. Continent equals Europe. So if we print that, we're going to see that we have each country multiple times, and you can see that we have different years. So we can plot the evolution of the population, the evolution of the GDP per capita, and so on. We can plot evolutions. And because of that, we can use a line chart now. We're going to say figure equals, and then px dot line. And we're going to say that the x value is going to be the year. Or actually first again, pass the data set. The x value is going to be the year, and the y value is going to be, for example, the life expectancy. And the color is going to be the country. And besides that, we can just say figure show. And there you go. You can see this chart shows the development of the life expectancy in the individual countries in Europe. And the good thing here, the interesting thing here is that this chart is already interactive. So I can say, for example, I don't care about Belgium. I don't care about Croatia. I don't care about the Czech Republic. I don't care about Denmark and so on. And I can just check off the individual countries here. And I can say I only care about Austria, for example, compared to Switzerland and Spain and Serbia and Portugal, and that's it. That's what I care about. And now I can see that I get this graph here, and I can just look at this data and compare it. I can, of course, then again change the countries, and of course I can also plot different values. So I can say, okay, I don't care about the life expectancy. I care about the population development. And if I do that, okay, this graph doesn't look very interesting. Maybe if we zoom into the area down here, we can see more nuances. But this is what we can also do here. Now, we can also go ahead and compare the individual, the population development of a single country, but not with a line chart, but with a bar chart. So we can go ahead and say, for example, Austria, which is my country. This is why we're going to look at this one. We can say Austria equals, and then, or let's call it Austria data equals px data gapminder query, and then the country is going to be, actually let me use double quotations here and single quotations here. Country is going to be Austria. Now we can just display the data here. You can see that country Austria, continent Europe, and we have the values for the individual years. And now we can just go ahead and say figure equals px.bar, and we can say Austria data is the data set, X is the year, and Y is the, what was it? Population. Wanted to see the population development. And we can also say, for example, the color of that individual year. We also want to know how good was the life expectancy here. So we can say life expectancy is the color of the individual bar. And then we can say figure.show. And you can see that the population is increasing. This is indicated by higher bars, but we can also see that the life expectancy is getting better and better, because the more we go to the right, so the more we go into the present or towards the present, you can see that the color of the bars changes. Now, I'm not sure if that is not true for every country. Which country had a bad life expectancy? Turkey, or yeah, was it life expectancy? Yes, let's look at Turkey, if that's the case there as well. Let's look at that. No, it's also increasing. So it may be low, but it's also increasing. Is there a country that has decreasing life expectancy? I hope not, actually, but maybe we can see the differences there. Romania, no. Here you can see the population is actually falling, but the life expectancy is increasing. Maybe we can look at a different one. Maybe we can say the color is not the life expectancy, but the GDP per cap. And then you can see, for example, here, the GDP was rising and then falling again, then rising again. So you can see development. Let's see what it's like in Austria. There you go. So this is how we can plot a very simple bar chart, a very simple line chart. Now let's do something else. Let's say, for example, what was the country with a very high life expectancy we had, or with a high GDP per capita? Norway has a high GDP per capita. So let's go ahead and look at Norway's development of the GDP per capita as the Y value, so GDP per cap, and the color is going to be the GDP per cap as well. And then we're going to also say, in this case, that we want to have a different color scale. So maybe you don't like dark blue or purple to yellow, so you can say color continuous scale is going to be ice. Now you can look at the different names in the documentation, but in this case we would have these colors here, which are a little bit better, I think, because black means, or dark means, very low GDP per capita, and the more you go to brighter numbers, you can see that the GDP per capita is increasing. You can also take blue red, I think was called. Then red would be a high GDP, blue would be a low GDP. You can also reverse that by adding _R, and then you have blue being high and red being low. So you can play around with the different color schemes. Now, last but not least, let us also look at a pie chart to see the distribution of the population inside of Europe. So what we're going to do is we're going to take the Europe data. We're going to say figure equals px.pie for a pie chart. We're going to take the Europe data 2007, and we're going to say that the values are the population and the names are the countries. And we can also add a title, by the way, Europe's population distribution, for example. Of course, we need to show that as well. And then you can see we have a very simple pie chart with the individual countries. Of course, here again, we can also say, okay, let's say some people say Turkey is almost in Asia, so I'm interested in the European-only countries for some reason, so you can click off Turkey, for example, or you can say I don't care about specific countries. I don't care about Switzerland, Austria, and Germany because I don't like the German language, so I want to know how many non-German speakers do we have here for some reason. Maybe you also want to exclude Belgium then, because I think they have some German-speaking people. But this is how you can just use, how you can design simple pie charts with Plotly without specifying too many things here. simple and straightforward. All right, so let's get to the conclusion. How does Plotly compare to Matplotlib? And I was curious myself, so I went online and I looked into Quora, into Stack Overflow, into Reddit, into forums. I wanted to know when it is better to use Plotly and when it is better to use Matplotlib. And it's interesting because the two frameworks are kind of similar. They're both for data visualization after all. But then they're quite different because Plotly is more focused on the web, on the browser, and on interactive charts that are easy to make, whereas Matplotlib is more professional and more scientific because it has countless customization options. Now, in order to create some very good looking Matplotlib charts, you need to take some time. Oftentimes you need to write your own little mini framework to get it to work. But when you want to have the full customization, you can compare Matplotlib to be a little bit like Arch Linux. You can do everything you want, but you have to customize it in a little bit more complex ways. Whereas Plotly is just you run it, you set some parameters, and you can create wonderfully looking charts, wonderfully looking visualizations. Now, Matplotlib also has some additional libraries like Seaborn that are a wrapper around Matplotlib and make it simpler, easier to use, and easier to create just better looking charts. But at the end of the day, Matplotlib has an extremely huge amount of options and customization possibilities. It's more professional, used for scientific papers, and you should definitely use it. You should definitely know how to use it as a good Python developer. However, Plotly is perfect for web development and web visualizations, for interactive visualizations. It runs mainly in the browser, and a few lines of code are all you need to make wonderfully looking charts. Also, it is very awesome for exploring data sets. If you have a data set and you just want to look into it, you want to plot some different charts, you want to play around a little bit to see what this data set is about, Plotly is way more convenient than Matplotlib, because in Matplotlib you would have to write more code and more complex code to get the same result, the same interactive possibilities that you have with Plotly. For Plotly, of course, there are also some additional libraries, many different additional libraries that allow you to do things easily and more intuitively. And both libraries are, at the end of the day, very good. You should use both of them. Matplotlib more for scientific, professional stuff if you want to have more customization, and Plotly more for interactive or for web applications, for web visualizations, or for just interactively exploring new data sets. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video, and bye.